Go ahead.
Tidal.
My Tidal
It's
is
used
Tidal.
by barrages. I don't know if I said that. I don't really know what they are.
What was it?
Barrages, these things.
Barrages, huh?
That's how I read it. I don't know
Okay.
if that's how you say it. But they put them on the coastlines where there's tide channels or waterways, and they use the water to spin turbines and provide electricity or energy.
It uses the same fluids as hydroelectric.
Pretty much.
Pretty much, probably.
No, the sluice gates is.
Yeah.
It's very close. It's inexhaustible. It's inexpensive in the long term. Obviously, it costs a lot to make at first. It's like I couldn't get a straight answer, but it was like a certain amount of dollars per. I don't really know for how much they made. It provides a lot of energy because it's very predictable and consistent compared to like solar or wind energy, where you have to have like special circumstances. Like it can't be cloudy, or it has to be a lot of wind for wind energy. But for this, you just need the tide, which is pretty much always going on. The infrastructure and advancements has to be on the coastline. The two things you need are the tidal energy power plants, like the barrages or whatever, and the electrical grids to distribute the energy. It doesn't pollute the air, water, or thermal pollution. Some advancements to make it safer would be a better turbine design for these things, which harness the energy from the water, and better control systems for the operators. Also, more innovative mooring and anchoring solutions to make maintenance solutions better.
Is it a big environmental problem?
No, it has a little impact on marine life, but they're working to decrease that. But pollution-wise, there's nothing. So it's really safe, and in the long run, they said it's inexpensive and provides a lot of energy, as well as being consistent.
Why is it consistent?
Just because the tide's always going, compared to like thermal energy, where it only works
What
when
happens when the tide switches direction?
It's like when it goes back.
Yeah.
It also, I think, still spins the turbines in the barrages or
Yeah, does
the
it
power
work?
plants.
Does it work both ways and the tide goes out and then comes back in?
Yeah, it is.
What's causing the tides?
The moon.
The moon.
Okay, good. I just want some obvious stuff here. So the moon goes, that we're rotating around, and there's the moon. The moon can basically, it's gravitational pull, right? It's pulling the water, and then as it goes around like this, now it's pulling this water back.
Yeah.
And so you have high tide, low tide, right? The water goes out, and the water comes back in. And I believe these are set up to catch it both ways.
Yeah, it does.
Yeah, I don't know if you have to actually rotate, rotate the turbines or something so it comes this way, or if there's just turbines that catch it one way and the other turbines that catch it the other
I think
way.
they just have one turbine and they rotate it.
Okay.
But I'm not sure.
Yeah.
I didn't get into it too much.
So that's like a really good one because it happens every day, just nonstop. You know, as opposed to a river you got to have it's always flowing a certain way.
Yeah.
This is the tides are going to move it back and forth. So someone had a genius idea with this. So
Is most of the cost behind it making sure it's like not going to get destroyed by like hurricanes and like stuff
Yeah,
like
I
that?
think like that and making it more efficient, extracting the most energy possible.
plus any infrastructure where you're going to have to build it like basically underwater or out in the water is always going to be a lot harder to do as well. So
Yeah, they have to have it on like a certain spot where the tide's at like a minimum of like 5 meters, I think it said.
Yeah.
So that there's always water coming through it.
yeah.
That's it.
All right.